Afternoon, fourth graders. We are going to review the definition for heat that we talked about yesterday. So we have heat is blank that is in the process of being blank from one object to another because of blank difference. So you probably were thinking of this when you came in the room. Luke, what should be in the first blank? Heat is energy. And the second blank, Lisa, that is in the process of being transferred. And our last blank, Cassandra, because of, yes, temperature difference. So now let's look at our full definition. So heat is energy that is in the process of being transferred from one object to another because of temperature difference. Okay, so we're going to talk about this more later in our demonstration. Okay, so we know that energy is transferred in heat. Also, we started to investigate what we think water vapor might be, and we discovered that water vapor is tiny droplets that are in the air. So not so much a liquid, but I want you to start thinking about the states of matter and what you think water vapor could be considered. So to review, we know that there's 3 states of matter, and we know that matter is everything that takes up space. So a gas, do gases have color and shape? Tamara? No color or shape in gases. Particles, are they moving fast or slowly in gases? Right, definitely moving very fast and freely because there's lots of space in between the particles. And what about solids? Do they take the shape of the container? No, solids do not take shapes of the container. They hold a particular size and shape all the time. And particles, are they close together or far apart? Lisa, yes, they're tightly packed and they don't move a lot because there's not a lot of space. So then we come to liquids. And do liquids take the shape of their container? Most definitely, yes. You can think of when you pour a glass of milk, a liquid, you pour it into your glass, and then it's the shape of the glass. And similarly, when you drop your glass or you spill a glass of milk, the shape is going to be lost and the milk is going to be splattered all over your floor. So today in our demonstration, I want you to be thinking about how energy is being transferred and what states of matter you are seeing in our demonstration. But before we get started, we're going to do a think, pair, share activity, and I want you to think about walking outside on a cool summer dry morning and why when you walk through the grass you notice that your shoes are getting wet. So go ahead and jot down some ideas you have as to why the grass is wet when it hasn't rained. It's a cool dry summer morning. Okay, so a lot of partner groups talked about the grass maybe being wet, and that's why shoes are getting wet, and that this might be because the grass in the ground is cold because maybe it was a summer day where the temperature was cold the night before. So we're going to talk about this question a little bit later on after our demonstration, but let's first read our learning objectives for today. So by the end of our demonstration today, we will be able to define and explain condensation. As of now, we don't know what condensation is, but through our experiment, we're going to see this and figure out what exactly condensation means. We're going to be able to give examples of condensation, be able to describe how energy is transferred in condensation, and identify how matter changes in condensation. So we're really going to be learning what in the world condensation is. Okay, for this demonstration, in case you guys want to do it at home and teach your families, you will need a glass bottle, some paper towels or a towel, a timer, and a tub, some kind of big container where you can have water, where the glass bottle is going to be able to be immersed and fit inside so that the water will come up to the lid of it, and some ice cubes in there so the water is very cold. Okay, and to get started, you're going to take your bottle and you're going to set your timer for 2 minutes, and you're going to put your hands on your bottle and you're going to warm it for about 2 minutes. You want your bottle to get warm from your hands being on it. Okay, I have warmed our bottle for 2 minutes. Now I would like you to take your science journals out so we can record some data. And I want you to watch closely, and I'm going to breathe in and exhale into the bottle, and I would like you to write down any observations. Okay. Write down your observations. And next, I want you to make a prediction in your journal. What will happen after the bottle sits in the ice water for 2 minutes and then I do the same thing and I exhale into the bottle? Write down what you think you will see. Okay, our bottle has been in the water for 2 minutes, so I'm going to take it out and I'm going to dry it so there isn't any water on the outside. And I want you to get ready to make your observation of what's going to happen when I breathe in and exhale into the cold bottle. Look at your difference in observations, the warm bottle compared to the cold bottle. And what difference do we see? What is different about this cold bottle that was not on the warm bottle? Jen, what do you think? Yes, I would agree. There are water droplets that you can see on the side of the cold bottle that you did not see when the bottle was warm, before it was into the ice water. And so I want you to think about, why is there this difference? It has to do with our word that was in our learning objectives, which is what, Charlie? Condensation. Since my warm breath and the warm bottle were not different in temperature, there was no heat and the water vapor did not condense. But the difference in heat was enough to make water droplets form on the cold bottle. This was because of condensation. So I would like you to jot down some ideas of what you think condensation is and how you can describe it. If it took place and it is visible from the cold bottle and it wasn't with the warm bottle. So thinking about our experiment and what we know condensation is now, is condensation a heat transfer? Yes, it is. So what two states of matter did we see in our experiment when the bottle was cold? I blew into the bottle, and this was what matter? My breath was gas that turned into liquid. Great, so a transfer from a gas to a liquid. So we know that condensation occurs when vapor is cooled and changes its phase to liquid. Thinking back to our Think, Pair, Share question, who can describe why your shoes are wet when walking through the grass on a cool summer dry morning? Okay, so water vapor comes out of the warm air and condenses on the cool grass. Because in the summer, sometimes the ground can be cool, a lot cooler than the warm air of the summer weather. Okay, so now that we know what condensation is, let's think of some common examples. Besides the dew forming on the grass in the early morning, we have eyeglasses fogging up when you enter a warm building on a cold day. Or what about water drops forming on the glass on a hot day, which is similar to our experiment. So I want you to think of another example that you have of condensation, or it can be similar to what we talked about, and illustrate it and write a description of what is actually happening and why it is condensation. Tomorrow we're going to talk about the process that is opposite of condensation.